All right, let's jump right in. We are going to tackle a concept in JavaScript that, let's be honest, trips up pretty much everyone at some point, lexical scope. But stick with me because by the end of this, you are absolutely going to get it.
You've definitely seen this, right? You've got a variable named user over here and another one with the exact same name somewhere else. So how on earth does JavaScript know which one you mean? Well, it's not magic. The entire secret comes down to one single powerful rule. And that rule, you guessed it, is called lexical scope. It's the simple, kind of unchanging principle that tells JavaScript exactly how to look up variables in your code. Now, the most important word on this entire slide is wrote. See, lexical scope isn't decided when your code is running. Nope. It's determined the moment you write it, based on the physical placement of your functions and variables. It's static. It's set in stone.
This right here is the golden rule. If you walk away with just one thing today, please let it be this. Scope in JavaScript is all about where a function is defined in your code, not where it happens to get executed later on.
To make this super clear, JavaScript is what we call lexically scoped or static. Now, some other languages use something called dynamic scope, where the variables a function can see actually depend on where it was called from. But for us, in the JavaScript world, that doesn't matter at all. It's all about where you, the author, wrote the code.
Okay, that's enough theory. The best way to really get this stuff is to just see it in action. So let's build a really simple example from scratch. So we're going to start with an outer function. Just think of this as our main container, the universe for this little example. And inside this universe, we'll declare a variable. We'll call it outer var. Right now, its entire world, its scope, is stuck inside this outer function.
Now, let's do something interesting. We're going to nest another function inner right inside of outer. We've basically just created a box inside of another box.
And here's the magic. Because we wrote the inner function inside of outer, it has access to everything outer has. So when we call inner, it first looks around for outer var inside its own scope. Doesn't find it. So it just looks one level up to its parent, finds it there, and logs the value. Simple as that. This is honestly the perfect way to think about it. If you're in the inner room, you can see out the door into the living room. But someone in the living room can't just magically see into your closed room. The scope chain only looks outwards. It never looks inwards. Okay, that seems pretty straightforward, right? But here is where things can get a little bit tricky. Let's look at the trap that almost every developer falls into at some point. This is the core misunderstanding. Our brains are just wired to think that what matters is where we run the function. But you have to fight that instinct and just keep repeating our golden rule to yourself. So let's switch up our code. Notice the big change here. Instead of calling inner right away, the outer function is now going to return the inner function itself. We're basically handing it over to be used somewhere else. And now, look at this. We call outer, which gives us back the inner function, and we save it in a new variable called newfunc. Then, totally separately, way out in the global scope, we execute newfunc. So, what's going to happen? Seriously, think about it for a second. We're calling this function far, far away from where it was created, where that outer var is nowhere in sight. Is JavaScript going to find it? Or is this whole thing just going to throw an error? So here's how JavaScript thinks about it. When newfunc gets called, it doesn't care about its location, not one bit. JavaScript asks one simple question. Where was this function defined? And the answer is, it was defined inside outer. Because of that, it keeps its original connection to outer's scope, which, of course, includes outer var. And the result? It logs outer perfectly. And this right here reveals the most incredible part of lexical scope. The function literally remembers where it came from. It carries that scope, its lexical environment, around with it, almost like a little backpack. It doesn't matter where in the world you call it, it never ever forgets the variables that were around when it was born. Now, I promise this isn't just some weird academic puzzle. Understanding this behavior is absolutely crucial because it is the key that unlocks one of JavaScript's most powerful patterns. That's right. This entire behavior we just saw, a function remembering its lexical environment even when it's executed somewhere else, well, that has a special name. A name I'm pretty sure you've heard before. So if you're ever in an interview, this is how you connect all the dots. You use the proper term for that backpack of scope. It's called the lexical environment. You can confidently explain why JavaScript uses static scope, not dynamic. And then you deliver the killer insight. This behavior is precisely what makes closures possible in JavaScript. Honestly, this concept is the foundation for so much. Callbacks, event handlers, all the modern frameworks you use. Getting this right means you're not just writing code that works anymore, you're starting to truly understand why it works. And that, of course, leaves us with one final perfect question. We figured out that lexical scope is the thing that makes closures possible. But what exactly is a closure anyway? Well, that is a story for another time.